Today I'm going to show you how to convert a lamp like this from fluorescent light to LED light. I'm going to show you how to replace this fluorescent light bulb with this LED light bulb powered by this LED power supply from Magnifying. To do this job we're going to need 3 different tools: a Phillips head screwdriver, a pair of wire cutters, and a pair of wire strippers. We're going to need stranded 18 gauge wire, black insulated and red insulated, and then we're going to need 7 small wire nuts. We're also going to use a center punch to mark a hole. We're going to use a set of calipers to measure grommets, and optionally we're going to use some heat shrink tubing to cover wires. And we're also going to need an electric drill with a 5/16 inch bit and a grommet for a 5/16 inch hole. So one of the first things that you want to do before you do anything on a lamp like this is you've got to unplug it, because you can't have the thing energized with 110 volts AC. Okay, so the first step is to take out the old fluorescent light bulb. So we have to remove 3 screws to do that. These are 3 Phillips screws. Now we unplug the lamp and set it aside. The next step is to undo this plastic ring, which is held on by these clips. And then you have to undo these 4 screws. Now you want to make sure that you've unplugged this lamp before you do this, because now we're starting to get to the part where we're going to be in contact with AC voltages otherwise. Now these clips are sometimes a little bit difficult to deal with. There's 4 clips here, 1, 2, 3, 4, and you have to make sure those are loose before this will pop off. So now we're going to take this circuit board out. Remember, you want to have the lamp unplugged before you attempt any of this. And then we're going to cut these 2 wires as close as possible to the circuit board. And this now is trash. Now we're going to connect these 2 wires together, but first we have to strip both of them with some wire strippers. Okay, and we're going to connect them together with a wire nut. The reason we connected these 2 wires together is that we don't have enough room in this little area here to put the LED power supply in place. So we're going to have to wire this lamp a little bit differently than the way it was when we had the power supply that fit in there perfectly. These wires come from the power switch, which you can see right here. This is how you turn the lamp on and off. And we don't want this power switch to switch the DC that comes out of the power supply. We want it to switch the AC so that the power supply is only active when the switch is on, we don't want this active when the lamp is plugged in all the time. So we're going to have to locate this power supply in a different place at the base of the lamp where there's some more room to put it. Okay, we're going to put this LED power supply inside this box. There's enough room in here so that we can put this inside and it'll be nicely tucked away. And accomplishing that is to take the cover off. There are 7 screws that hold this thing on. Okay, there we we go. Now we have quite a bit of room in there. And this is the wire that comes down from the head of the lamp. And one side is connected to the white, one side is connected to the black. In general, the black wire is called the hot wire. It's the wire of death. The white wire is neutral, or very close to ground potential. And they are connected through this outlet to the power cord that goes to the wall, which is this set of wires right here. The black again and the white. Okay, so the first step here is to cut this zip tie here, because we want to separate the black connection from the white connection. These are the two wires that we're going to connect the power supply to. So the AC in of this LED power supply, we're going to connect it across these two wires right here. So we have to remove this crimped on wire nut to do that. So we're going to use our cutters, and we're going to try to save as much of that wire as possible, because we don't have a lot of it here. I'm going to try to cut it right there, right next to the crimp. Okay, there we go. Now we're going to have to strip these wires. And then we're going to make our connections with the wire nuts. Okay, so if you peel back this stuck-on label here, this AC-in label, there's a label underneath that indicates ACN, which means AC neutral, and then it says blue in parentheses next to that, and then ACL line, or hot, is brown. So in this case here, we've connected the blue wire, the neutral wire, to the white wire, which is important, and then the brown wire goes to the black lead through the switch. So the power comes in this way, goes up to the switch, and then comes back this way to the power supply. Okay, so now we're going to need to run some wires in parallel with this wire here. And in order to do that, we're going to have to take this apart so we can snake this wire through this square tube here. So that means that we have to take apart, pull these screws out here. And they're Phillips, so we just have to take them out. Now these little plastic bracket things are important. They have a nice brass sleeve in there that takes the compression of the tightening of the screw. But now we should be able to slide our additional wiring through this hole and parallel with the zip cord here. There's 3 more locations like this that we have to address. Okay, so we've taken out the bolts that hold this together, and now we're going to be able to snake a wire through this square tube up to this point here. And we're going to snake it. We're going to just follow this wire on its path, and then we're going to end up all the way over here. So here's the wire we're going to use. It's 18 gauge stranded wire. It's important to use stranded wire because this needs to flex as you move the lamp around, and stranded wire is much less prone to fatigue than solid wire. Now this wire here is going to carry the 36 volts that the LED power supply is going to put out on these wires here. So we're going to extend these wires here all the way up through this channel and bring the 36 volts up to the head of the lamp where we have our LED light bulb. So this wire, we're going to use the red and the black wire because that's the same color that we have on the LED power supply. This wire is bringing the 36 volts DC up to the LED that's sitting here because the LED uses 36 volts DC. It does not use the 110 volts AC that you get out of your wall socket. So we're taking our 18 gauge stranded wire and we're going to parallel the zip cord from the bottom of the lamp to the top of the lamp. So first we have to feed it through here, and this is the start of a long journey. You want to be careful not to damage the wire as we pull it through these holes. Now the tube is probably going to be the most difficult part. Okay, as you're feeding this wire through, you want to make sure you feed through each hole or each tube or each junction. Every time you do a feed, you want to feed all the wire you're going to need because you're only going to get one chance to do that. So we need to make sure that we've pulled enough to get all the way around to our destination before we go and feed it through the next piece. And it doesn't hurt to be a little bit on the over side. I'm going to pull like an extra foot or so to make sure. Okay, and we want to do that to each and every piece. We don't want to try to pull through more than one piece at a time. And we want to make sure we're paralleling the zip cord here. Finally, we want to thread the DC wires through the last little plastic piece. So we're going to do that right here. As you can see, we have plenty of extra wire. Not going to be short. And then we have to push this back down here. Oh, there's a piece that goes outside here. There we go. And then we just have to put the bolt through and everything should be fine. Okay, and now we're going to do the bottom piece. And now we're going to hook up the last piece again. It's a little tricky to get all this lined up. There we go. And we just spin this nut back on. Okay. Now we have to connect the red and black wire here to the red and black wires here. We're going to do that with wire nuts. So the first step is to cut these wires. Then we have to strip them down. So here are my two wire nuts, and we're going to wire nut the red to the red and the black to the black. So you match the ends of the wires up, and you put the wire nut over them and you twist clockwise until you feel them catch. And here actually I trimmed a little too much wire. You want the trim to be about equal for both wires because you want the ends of the insulation and the ends of the wires to match up. I'm going to trim off a little bit here, make this match up. Okay, and then we're going to put the wire nut over both wires and twist clockwise until we feel it bite and get it good and tight. And you can make sure you have a good connection by tugging here. And you don't want to see any uninsulated wire. Okay, now we have to push this all together and put it together with these 7 screws here.
So what are you doing now?
Okay, now we're putting in the 7 screws that hold the outlet plate onto the box. And we're just going through one by one, putting in the screws. And got the little power supply buried in there.
The LED power supply?
That's the LED power supply, yeah. Turns out there's just enough room to put it in there. Okay, so that takes care of the bottom part. Now we're going to drill a hole right here, right next to where this wire goes in, so that we can get the red and the black wire inside the little box here, where we can connect it up with these wires. We have to get this connector connected up to these wires inside the little box here, inside the lamp housing. Grommets are a way of protecting wires when they pass through metal. Because if you drill a hole through metal, inevitably you get some sharp edges, and then if the wire rubs against those metal edges, the insulation will abrade away, and then you have a potential for copper wires to be in direct contact with whatever metal they're going through, and that can cause a short or energize the entire lamp housing and cause a shock. So whenever you pass through metal, you want to have protection, and that's what a grommet does. It protects wires going through a hole from rubbing up against the metal. Okay, here's my collection of grommets, and I'm gonna choose one such that it's comfortable getting the wires through. I don't want to make it too tight. So I think this one might be too small. Let's see. If we try to get the wires through here, it's kind of tight. So I'm going to go the next size up, which is like this one here. And we want to see that the wires go through easily. See, that was very easy to get the wires through.
Great.
Now the next question is, how big a hole do we need to drill for this grommet? Well, the grommet has a groove there, and the hole needs to be just big enough to pass the inside of the groove. So we take these calipers here and we go and we measure the inside of the groove, and without squishing it too much. So here we can see the grommet, it's a little bit squished, so we probably want to open it up just a tad. And we're at 0.3 plus 0.02 roughly, 0.025. So that's 0.325, which we'll find a drill for that. I'm going to use a center punch, and I'm going to mark where I want the hole, which is like right here. And then I take my drill, I plug it in, and this is about a 5/16 inch drill. Okay, and now here we have the grommet, and we should be able to just stuff that in and have it protect us from the sharp edges of this hole. This is a rubber grommet. There we go. Now the rubber grommet is fully seated, and if you look on the other side, it should have popped out. It's popped out onto the plastic side, so it's actually protecting us from the metal and the plastic. Now we have a place to feed the wire through in there, but before we do that, we're going to protect this wire with a little bit of heat shrink tubing, and to figure out how much heat shrink tubing we need, we're going to make it as long as this wire, because that's been already set up to be just the right length to provide all the flexibility we need for moving the lamp around. And I'm going to use a pair of scissors to cut the heat shrink tubing, and then we're just going to push this wire through the heat shrink to the other side. And I'm going to snug it all the way up to like so. Then we feed it through. Now we feed it through the grommet into the housing. And now we're ready to go back up to the kitchen where it's warmer and finish the assembly. Okay, so we got the grommet in place, we got the wires threaded through to the housing, and they're a little bit long here, but you know, there's always good to have extra wire. So I'm going to trim off, you know, maybe 6 inches, but I'm going to leave a good healthy 10 inches there, because you never know. And we've got plenty of room in that housing now to coil up the extra wire. So we're going to trim back the insulation here. There we go. 1, 2, and according to the instructions, you hook up, you know, the plus side to one side and the minus side to the other side. There's no polarity on this, apparently. Just seems a bit unusual. So we take a wire nut here. You can twist the wires a little bit together, but the wire nut will do most of the twisting for you. So sometimes you twist the wires together just because it's convenient to hold it together before you get the wire nut on, but it does make sense to twist each individual wire so that you don't get a fraying of the strands. You know, again, you want to match the ends up, and you wire nut that together like that. So this lamp here, the power supply that converted the 110 volts that came in here into a current and voltage that's appropriate for a fluorescent light bulb, that circuit was in this little bump here that stuck out. But the circuit that converts the 110 volts into current and voltage suitable for the LED is too big to fit in here. It's not the right shape. It wasn't curved like this. It was too big. So we decided to put it in here because this is a much bigger cavity and it had room in it, plenty of room to put, even though there's an outlet here, it had enough room to put the power supply here. But what that meant is we had a conundrum because the power comes in here, it would feed this outlet, and then the power would go all the way up here, and there was a switch here that switched the AC power before it went to this circuit board that was in here. But now the circuit's down here, but we still want to use this switch, and we want this switch to switch the AC because we don't want the circuit powered up drawing phantom power from the AC lines when you have this plugged in. So that meant that we had to send the AC up all the way up to the switch and back down to here where the power supply is, and then we had to send the output of the power supply via this other wire that we snaked in parallel with this one so that the DC then comes back up here. This particular bulb requires a separate power supply. It runs off of DC, not the AC. Some LED bulbs have a converter from AC to DC built right into them, but this one doesn't. So in a lot of fluorescent fixtures, the circuit that converts the AC into the power suitable for the fluorescent bulb, that circuit sits right in the middle of the ring because it's an empty space that's often, you know, not good for anything else. But in this case, this is a magnifying lamp, so it's important. I mean, the whole purpose of having a ring light like this is so that you can see through the middle of it and have excellent illumination on what you're looking at, which means that the space in the middle here isn't available for any circuitry. And so that's why you have this bump here on the side where they created a cavity to put the circuit. Unfortunately, that bump wasn't big enough for the LED version of the same circuit. Now for the final assembly, we're going to want to coil up this red and black wire inside this housing here, so that the wire, because we want the wire nuts to stay in this housing as well. And we want this cord to stick out as far as possible, so that we can position the lamp wherever we want. This cord here is the part that is going to be outside the housing. It plugs into the LED ring. And there's a little slot here in the housing where it can exit the housing. Okay, now we just got to get these screw holes lined up. Okay, now the thing about doing this conversion is that the connector here is very similar to the connector that was used for the fluorescent light bulbs. So someone could inadvertently put a fluorescent light bulb in here, and that would not be a good thing because they're not designed for the 36 volts that is now coming through that connector for the LED. So they give you a sticker to put on here to warn people that, you know, this is no longer a fluorescent fixture. This bulb here, the light only comes out on one side, this side. The back side here is opaque. There's no light that comes out here. So this inside of the housing here doesn't need to be white because it doesn't need to reflect any light down like it did when you had a fluorescent bulb in here, which created light in all directions. Which means that we can put this sticker here in here, and this sticker here is to warn people that the electricity coming out of here is no longer what is compatible with a fluorescent light bulb. It's only compatible with an LED. So we're going to slap this sticker in here, and that will give people a heads up as to what we've done here. Okay. Now this LED bulb here is supposed to last for tens of thousands of hours, and I suspect that this entire lamp here will be completely junk by the time you need to replace this bulb. So it may never come to a point where anybody's ever going to read this sticker. And also in 10 years you may not even be able to buy fluorescent light bulbs anymore because they've all been obsoleted by these LEDs, which use half the energy and put out the same amount of light that the fluorescent bulb did. Now we've snapped the ring in place here, and then the last step is to take these little clamps that hold the bulb in place and install them. I'm going to put one of them in place without the lamp in there because it'll be easy to get the lamp in with only one in place. This screwdriver is a little bit magnetized, which makes it easier to get these screws in place because it's pretty tight in there. Yes, the old fluorescent light bulb used 22 watts. This thing uses 11. And there's no mercury involved, which is nice. There we go. We are done. Okay, so now we're going to put it back in service. So we're going to plug it in, and then we insert it back into its holder. And we have a couple of springs here that we haven't put on yet. Springs go like this, they keep it from flopping down like that. There we go. So now let's see if it works. Hey, look at that. And that's how you convert a fluorescent lamp like this into an LED one.